That we will start with some overview of machine learning concepts, like the concepts and terminologies used in machine learning. Okay, first we will see the types of machine learning, right? Then the key components, workflow, challenges and consideration, and then we will see some applications, okay, of machine learning in real world scenario. Okay, yeah. So starting with the encoding methods, right? So we have to first of all cover the topic that will be that is our encoding method. Okay, so as I explained you earlier, right? So we have so until till now you have basically have an you would have got idea that we have to, yeah, okay. So before that, let me ask you if you have any doubt till now or in yesterday's class. Was And one more thing, are you taking means like a short notes, like are you taking the topics, are you noting them down? Yeah. Oh, okay. Yeah, I forgot to tell you that means while I am explaining you, you may just note down these concepts on your diary or okay, so on your notes. Okay. Okay. Then it's fine. Okay, then no problem. So yes, so we have some encoding methods, right? Encoding methods, so that we can convert our categorical data into numerical, right? So we will also see at the end when we will be doing this workflow, then we will see where these topics are used, means where we have to perform this encoding method, right? So there are majorly two techniques in encoding. One we have dealt with, that is your ordinal encoding, okay, and another one is one hot encoding, right? So now what is the difference basically, right? We have seen the ordinal encoding and now we will be seeing the one hot encoding. Okay, so to explain you what hot encoding is, one hot encoding is basically you may think of it as a technique that will be used in your machine learning, okay, and data pre-processing. Okay, so we will be using this technique on our data pre-processing. So to represent to represent categorical variables as a binary vector, okay, to represent your categorical data into our binary vector. Okay, so it is particularly like useful when dealing with like algorithms, okay, that require only numerical input, like, okay. So it transforms the categorical data into format that can be easily understood by machine learning model. Okay, so now let's see how it works. Okay, suppose say you have categories like color. Okay, so this is the major difference in your one hot encoding and your ordinal variable, that in ordinal variable, right, if you remember, we have to have some order in this ordinal encoding. We have to have some order like good, better, and best, right, and worst will come at the first. Okay, so here we have a order, right, and like this is your review, and you can order like high school, right, bachelor's and postgraduate. Okay, so this is your basically your order, right? So when you have categories with like these orders, so your ordinal encoding methods are preferred, right? Like you will be considering worst as 0, good as 1, better as 2, and best is 3, right? Similarly for high school 1, bachelor's 2, and passing also postgraduate 3, right? So this is your ordinal encoding. But what your one hot encoding is, basically here you don't need to have like order. Like you may have color, that is your red, blue, or green, right? Here you don't have any order. So if you will specify that represent red as 1 and blue as 2 and 3, so it may lead some error, right? So because here we are saying basically that 2 is more important than red, right, when we are giving it number. But it is not the case. Like red and blue might be the same, means they are not comparable, right? So in this scenario we tend to use this one hot encoding method. Okay, so how this will represented in a binary vector representation. Okay, so how we can represent it in a binary vector representation. Okay, so now our task is to represent this data in a numerical form or in a binary vector form, right? So what we'll be doing is, we will in the one hot encoding we will convert each category into a binary vector of length equal to the number of categories, right? The length equal to the number of categories. Okay, means here we have 3 categories, right? 1 2 3. So we will create binary vector of length, right? Means here we will create 3 column, 1 column, second column, 3 column of equal length, right? So we were having 3 categories, red, blue, green. Now we will create 3 column or 3 vector. Okay, and each position in your vector will correspond to a category, right? This will represent your category, and only one position at a time. So this will be your hot. Okay, so suppose let's take example, if I want to represent these variables, right? So I will say suppose I want to red, blue, and green. Okay, so suppose you have data like data 1 2 3 data, this is your row, right? Observation, first observation. Okay, so in first observation suppose you have a column that is your color, right? So this is our normal data. But how we'll convert it into a binary is, we will create 3 new columns. Okay, and now what we will do is, each position in the vector will correspond to a specific category. Okay, so suppose now here we have these are 1, suppose you may name them like 1 2 3. Okay, suppose now if we want to represent that this particular column is contain the category that is your red. Okay, so now what we will say is, we will specify this position as 1. Okay, 1, and the rest will be like 0 0. Now when we have category blue, so that second position will be 1. Okay, other will be 0. Now in the third, starting will be 0 and the last will be 1. So now what we are doing is, we are dealing with the problem of ordering them. We are not ordering here, right? Now we have just have given them a number, and now we have also converted our data into numerical format. Now if you are given with just this data, if I will hide this, okay, if I will hide this, now if you know that if you know about the data, now you can easily say that yes, if the first row is 1, that means this is your red color. If your second column is 1, that means your color is blue. If the third column is 1, or we may say 1, or we may say hot. Okay, we use a keyword that is your hot. Okay, so if the third column is 1, that means you have a color green. Okay, so this way we have converted our categorical variable and we can represent it into a numerical numerical format. Okay, so this is a theory behind this one hot encoding. Okay, now let's try to see how we can use it in a code, and then I will give you some points like when to use them, like when to use ordinal encoding, when to use one hot encoding, and some advantages for both of them. Okay, and then we will jump into the overview of machine learning concepts or the terminology. Okay, like most of them we have covered, and but we will be doing them in ordered way. Okay, so starting with let's do the ordinal encoding. Okay, first, like we have seen already. Okay, so unlike one hot encoding that we have just seen, ordinal encoding assigns integer, right, value to the categories based on their order or hierarchy. So it will assign the integer value to the categories. Like this is the first category, so it will assign any integer value to it based on the order of hierarchy. Okay, so it will assign this base value basically. Okay, so here I am taking a dummy data. Here we have just created this. Okay, so I will try to plot the or create make this education level into numerical format. Okay, so this is a data converted into data frame using this pandas data frame function, and now just displaying it. Okay, so this is your data. Yes, so now if you see yes. So now if you see, here we are converting it into a numerical form. Okay, so here we are just mapping it, like the order, we are giving the order, like that high school stands for 1, means replace the basically value of high school with 1. Okay, and replace the value of bachelor's with 2. Okay, master's with 3, PhD for 4. Okay, and now here we are using a map function. Okay, so that will basically change these value for all the values for this column. Okay, for this educational level column, these values will be changed for their key value. Okay, so this is the key value, sorry, key, and this is your value. Okay, so for this key, your it will be replaced with your value for every observation. Okay, so similarly for bachelor's, master's, and PhD. Okay, so and that will be stored in your new column. Okay, here new column will be created, that which will be named as education underscore level underscore encoded. Okay, so this is your output. Okay, like high school 1, bachelor's 2, master's 3, bachelor's 2, PhD 4. Okay, as we have seen on our previous session also. Okay, so this is the one way. But what if we don't have this order? Okay, we don't have the order. Here we are dealing with like color. Okay, red, and we are dealing with fruit also. It is your categorical data: apple, banana, orange, right? Apple, orange again. Okay, so now how to display this data in the our numerical format? Now we have just this column in our numerical data, right? Okay, so we are doing the same thing, and this is your at your display we have our data set. Okay, like you can see this, the first observation apple, fruit, color red, price 1. Okay, now just imagine me, how can we convert this into a numerical format, right? First of all, we have to do it for fruit, right? We have to create assign new values, sorry, new columns for every fruit in it. Like for apple, we have to create a new column, right? And it will be 1 only if your fruit is apple, and another column that are your banana, orange will be 0 0. And for banana we will create we have 3 columns, right? So the column which have apple will be 0, and the column with your banana will be 1, and your column with orange will be 0 again. Okay, so similarly for all the values of fruit, like for orange. Okay, so here we have 3: apple, banana and orange. So 3 column will be created: fruit, and for fruit, right, fruit name. Okay, and similarly for color also, like here we have red, yellow, orange, like 3 color we have. So we will create another 3 columns, like for red, new column. So it will be 1 basically whenever the value for color is red. Okay, so we'll be doing the same thing for it. So like now we have to create 6 column, new 6 columns, right? If you want to perform, if you want to show this data using our one hot encoding method. Okay, so if we would be using the ordinal method, so just like we would be using 1 column for this one color, right? But now here, since we are using one hot encoding, so every category will take 1 column. Okay, so now here we are just applying it. Okay, any doubt till here, or confusion, or any question? Okay, okay, so here now we have 2 values like fruit and color. Okay, so we have to one hot encode them. Okay, these columns. So we are using get dummies that is inside our pandas. Okay, so that will help us to perform this technique. Okay, and here at the first parameter we have to pass the data frame name, that is our df. In the second, yes, let me run this. Yes, in the second we have to pass the column on which we have to perform this one hot encoding method. Okay, and here is the prefix, like fruit and color. Okay, so like what will the prefix for these apple, what should be the what should return at the first starting of this apple. Okay, so this is your optional, you can give it or not. Okay, so this is basically, here you may see like fruit underscore orange we are having, because I have given the prefix here fruit. Okay, so now the data is encoded, data frame is encoded. Okay, now if we will display it, we will see we got 6 columns, new columns: fruit apple, fruit banana, fruit orange for fruits, and for colors we have orange, red and yellow. And now every time any value will be there, so it will be specifying it as 1. So for apple we were having 1, and if you want to check the which color it is, you will check orange, no, it is not orange color. Sorry, orange color, it is not orange color. Red, yes, it is red. And yellow, no, it is not yellow. So now we got that information that apple that is of red color is priced at 1 rupees. So now this data is presentable for our computer or for our machine. Now the second row is your banana with yellow color. Now if you will see here, banana with yellow color, right? The third row we have orange with orange color. Okay, so the orange with orange color. In the fourth row we have apple with red color, and similarly for here orange with orange color. Okay, so this is the way how we do it. Okay, so this was a short data with like just 5 observations. If it would be like in lakhs or 10 lakhs or millions of rows, so then it is very easy or handy to use this pandas. Okay, so this is the way how we do it in our Python. Okay, so now let's see when to use it. Yeah, please. Hmm. Hmm. No, because it's just here you are saying. Okay, so it's just in like if I will do this, means basically it's just but I say that it is not fitting in here. So I think there I haven't tried it, but I think like because it was taking space, no, so that's why. mm, 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 no, actually see, it is not going in the next line. It is on the same line, but just because it is not coming in the same line, it is just displaying you in the second line. But yes, yes. Hmm. Okay, yes, but still I will try to recheck it, and if there would be any solution that we can do it on the same row, I will let you know. Okay, because I haven't tried it yet. Okay, so according to me, it's just like a way of to display, like it is not stored somewhere that this line should be the next, but it is just a way of displaying it. Okay. Hmm. 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 Yes. Hmm. 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 Okay. Yes. So any other doubt regarding any function or how it works? No? Okay. So yes. So you may just give it a look here. Encoding method. Okay. Okay. So now should I continue? Okay. So just quickly, just let me give you the advantages of or when to use them. Okay, so you have seen that one hot encoding. So are these notes beneficial to you, means like I should create them, or just like when I speak, or it will be fine? Means I'm saying that are this writing these notes will be helpful, or it's just because because it's just like taking some time to write now. That's why I'm saying. Okay, so when to use them? Okay, so basically your one hot encoding. Mm-hmm. Oh, okay, okay, okay. Yes, so basically your one hot encoding, we have nominal data, right? So there is no inherent. There is a term that is nominal variable and ordinal variable. Okay, and there are also yeah. Okay, 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 okay. So yes, so there are variable types of variable, right? Yeah, in numerical type also we have no, sorry, uh, yes. So it help so your one hot encoding is basically helpful for where there is no inherent order. Okay, basically, right? And your in ordinal ordinal data is for ordinal encoding is for ordinal variable, right, that have some uh, hierarchy. Okay, and basically your one hot encoding is used when the number of unique category is large. Okay, so the one hot encoding will result like in sparse when there are a large number of cardinality, right? Means like the unique value per category. Like if you have like colors, if suppose you have 20 different color name, so then you have to create 20 different categories, right? So that will lead to your sparse data. Okay, So there are some advantages, like you preserve a uniqueness or one hot encoding. Each category get its own binary column, right? So it basically it preserves the uniqueness for each category. Okay. And basically their one hot encoding is your best suitable for your algorithms, like suitable for one hot encoding is for your tree based algorithms, right? Like you will be seeing on the further classes, there are algorithms like decision tree, and you have your random forest. Okay, so these are some tree based algorithms. So on these your one hot encoding is helpful. On the other hand, you have ordinal encoding, so it is best suitable for your uh, it is best suitable for your like other techniques like linear regression. Okay, and for your XGBoost techniques. Okay, so let me write just a simple example for like a linear regression or like other algorithms except these three algorithms. Okay, linear regression. So in that case you may try to use your ordinal data. Okay, and just one thing you have to consider while doing this one hot encoding is your one hot encoding can basically lead into your high dimensional data. Okay, so there is a concept basically in machine learning that whenever your number of columns increases, okay, so you may just note it down the topic that I'm seeing and try to research about it. Okay, so why it happens. Okay, and then we will discuss on the further class that why it is so. Okay, so when your number of column increases, right, suppose say we have 10 columns, you are getting accuracy of something about 80%. But if you see that if I try to increase the column number with significant amount, significant number, suppose I'm taking 25 columns for now example, now you will see that my accuracy is getting lower, like 75% or even lower, and actually the time that is required for this training purpose is getting higher. Means I am giving the time higher, I'm giving the number of columns higher, but I'm getting the accuracy low. Okay, so there's a concept that is your that is your curse of dimensionality. Curse of dimensionality. Okay, so due to which as your number of your columns increases, your accuracy tends to decrease. Okay, so there are some techniques like that we use, like PCA, principal component analysis, to get to so that we cannot so that we do not face such problem, or to reduce the number of columns. So in this technique basically we try to take two columns and we'll try to merge them, or we'll try to make it into a one column. Okay, so therefore we will try to reduce the number of columns here. Okay, so that's why your one hot encoding may lead to some maybe become a disadvantage for you, for your algorithm, sometimes for all your algorithms, right? So you have to take it into consideration while you are using it. Okay, so that you don't have much number of columns. Okay, I think now we have covered all the points, like for ordinal variables you have compact representation if you want to. Yeah, so like on your ordinal data, right, ordinal encoding, your data will be like compact, right? So your you can have your compact representation, like in the same column you are getting all the categories, and your dimensionality is also reduced. So this is the advantage of your ordinal data. Okay, So winding it up for this uh, encoding methods, and let's just start with your these topics. Okay. Yeah. Hmm. 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 Yes. Hmm. 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 No, in see, see, you just have to keep these little bit concepts in mind. But most of the time, you will like here. I told that one hot encoding works best for your decision for your tree algorithms. Just you have to keep these little information on your mind, and like most of the time, then you will be doing trial and error till the technology of now. Now if the further upcoming technology like our libraries increase on our Python, then maybe we have some library that will tell us that which of the algorithm will work best for our data set. I think there are some of the libraries currently that will tell you the starting of the by just seeing the data set, it will tell you which of the technique will work best. Okay. So but most of the time on the traditional way we have to do it and try and error, like you will do first one hot encoding and see the accuracy, for ordinal encoding just see the accuracy, come back again, feedback loop, you will change the hyperparameters, right? So this is your workflow here. So this part comes in your workflow, right? You come back again to your data set, come back you again to your modeling process, change these encoding methods and see the changes and see the change on your output. Okay. So hmm, 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 hmm. Okay. Yes. Now let's start with the types of machine learning. Okay. So there are basically at the core you have three types. Okay. One is your supervised learning. In this technique, the algorithm is trained on your labeled data set, okay, where each input has a corresponding output. Okay. So like here I'm passing the some rows and it have the specific predicted value. So this will be a supervised learning. Okay. Another is your unsupervised learning. Okay. Unsupervised learning. Okay. So this algorithm is basically given an unlabeled data set. Okay. And it will find the patterns or the relationship within the data. Here you are not giving any input or output columns or output data. Okay. You are just giving the unlabeled data, you are not labeling it, and it will basically find the patterns or relationship within the data. Okay. And at last you have a technique that is your reinforcement learning. Okay. So this is the most interesting technique. Like here what you do is here you give some you make rule, right? So that if your while training your model does something, like if it you give it some, you make some rule, like you are creating a game. Okay. Suppose say you are teaching your model to play chess. Okay, so we will create certain rule that your whenever suppose say take, let's take a easier example. So not, let's not take the example of chess. Suppose say you just create some rule, and if your machine learning model do some good stuff like this, there will be a list like it will be specified that good or bad. Okay, so if your machine learning model performs some good result, so it will be treated as it will be given some uh, what I say to it, it will be given some points. Okay, bonus points. And whenever it does something bad, it will be given some minus points, so it will be a negative feedback. And whenever it do some good thing, it will be a positive feedback. So your model will look for positive feedback. So how it gets a positive feedback again and again? So it basically you don't yes. So the word for it is basically your reward. Okay, so it gets reward. Whenever it does something good, it will get reward, and when it does something bad, it will get punishment. Okay, so it try to avoid the punishment and tend to get it wants like rewards. Okay, so this algorithms learns by interacting with your environment. Okay, you will have some specified environment and your model will interact with it. Okay, and it will receive feedback, okay, in the form of rewards or penalties. Here I used punishment, or you can use penalties. Okay, it will receive the feedback in the form of your rewards like good thing or the base of punishment. Okay, so the main objective of your machine learning model will be to learn a policy that maximize your cumulative reward. So at the end your reward should be higher. Okay, so the main thing of your model in the reinforcement learning should be like your reward should be higher. Okay, so this is the pretty much what reinforcement learning does. Okay, so to give you an example of your reinforcement learning, your game playing, like you have seen playing game in like bots, right, in some game like PUBG or COD or Dota, or means like there are different games. So there you have seen like robots playing their game whenever the player is offline, right? So those games those players are controlled by these techniques, these models that are created using reinforcement learning. Another technique, another application is your or another example of your this technique basically is your robotics. Okay, and similarly for unsupervised, your examples would be like clustering. If you want to cluster your data, you are given with some unlabeled data for your unsupervised learning, and your data and your machine learning model will see your data and will try to cluster them. Suppose your data points will be plotted like this. Here you have age, here your salary. Okay, so here the lower age people on the ascending order, and here your salary on your ascending order. Okay, so lower age people are getting lower salary, fine, makes sense, and your higher age people are getting higher salary. Okay, so what this unsupervised learning is doing is, here you haven't labeled anything, like here you haven't labeled input or output, right? Here you just given the data set as it is. So what it will do is it will make clusters of them. It have made this cluster and it has made this cluster. So your unsupervised learning is responsible for making clustering or your dimensionality reduction, as discussed just earlier, right? Like you can use it to reduce your dimensionality, like if you want to reduce the number of columns. Okay, so in this case you can use your unsupervised learning to check whether the column is important or not, so that you could keep that or remove it. Okay, and similarly for supervised learning you have some techniques like your, that I already told you, that classification. Like you will be giving a data set, suppose classification or regression. Okay, so like classification for your, whether your images of your dog or the images of your cat, so that will be your uh, regression. Okay, and yeah, so regression will be your, like your predicted value, like your continuous values, like your, while we are doing house price prediction, so it will predict your, it will try to predict your price of your house on the basis of square foot or number of rooms and locality. So on these basis of these inputs it will try to predict your output. Okay, so this will be your regression. So this comes under your supervised learning. Okay, and like your flight price prediction, like what will be the flight while the holidays or the certain days. So it all comes under your regression, and because it is your input and output, here you need input and output, here you need unlabeled data. And here your data, here your machine learning will be given a environment, and on those environment it will be given some policies that it have to follow, and on this basis of this policy it will be given a reward and punishment, or you may say penalty. Okay, so these are the basically your types of machine learning. Okay, so they are this is the pretty much it. Okay, so now we will see what are the key components. Is this theory making you feel bored? Means are you getting fine? Means are you learning something, or are these terms already known to you? Means are these something new to you? Means are you getting some new, or just I'm repeat, means you are aware of these things? Am I audible now? Means clearly? Hello, hello, hello. Now can you hear? Okay, okay, okay. Yeah, your feedback will help me to improve, like to make the thing you like. I will try to improve, do it more, and if you will have some negative feedback, so I will try to remove them or reduce them. Okay, so you should encourage the negative feedback as well. Okay, thanks for the positive feedback, by the way. So now let's continue with the key components. Okay, so the key components for your, basically your for machine learning, are the some topics like your features and labels. Okay, so I have already explained to, like your independent and dependent variable, right? So similarly to them, there is another name for them is feature and labels. Okay, labels. Okay, so your features are basically your to say they are your independent variable. Whenever you will be reading the articles or blogs, you will not see that this is your independent means these are your input value or your output columns. So they will use this term. They will say features. This is your features, this is your label. So label is your dependent variable or your target value. Okay, or you may say it as your predicted variable that you will use to predict. Predicted variable. Okay, so that will be named as a label. Okay, so the target value variable that a model aims to predict in your supervised learning, that will be your label value. Okay, and your features are your input variables or attributes that are used to make predictions. Okay, so this is the term basically used for your columns. Okay, so there is another term that is your testing data set. First I should write training data set, training set, and you have a test set. Okay, so oftentimes it is like your 70 to 30 ratio, or it is your 80-20 ratio. Okay, 80% training data set, 20% your test data set. So training data set is the subset of your original data set, right? So this was your, suppose your original data set. So 80% of this is the subset of your original data set, that will be used to train your model. So this data set will be given to your it will be used as your, it will be feed to your model. Okay, and your this test data set will be your unseen data that your model haven't seen already. Okay, so using this we will try to predict. So see, in test data set you have two things, right? In this test data set you have features and labels. Also you have also labels, right? In training data set you have columns that are features and labels, right? While a training data set we are using features to predict labels, right? Similarly in a test data set what we will do is we will use features, okay, of original data set, but we will try to take the predicted value from our model, that will be your predicted value, and we'll compare that with your label, that is basically your target value. Okay, so that will basically help you to evaluate your model performance. Okay, so these are the two different terms basically used. Okay, now the another term that you will see that you would be seeing again and again is that model. I'm saying again and again model. Okay, so what this model is? So your model is basically your mathematical representation of relationship between your feature and your label. Okay, between feature and label, like your input value, output value, input and your output. This is your model, the relationship between your feature, input and output. Okay, so there are different types of model. To give you some of them are your decision tree, you have neural networks. Neural network basically comes on your deep learning, right? You have heard of the term deep learning. Similar to machine learning, you have deep learning. Okay, so deep learning is a little bit complex, not complex, I would say. There are some different terms basically. Okay, and we have like support vector machine, SVM, called in short we call them SVM. Okay, so this is also some model. Okay, so similarly to them, these are the models. Okay, we call them model. Okay, so they are basically the representation of the relationship between input and output. Okay, now another term that often used is loss function. Now what your loss function is, basically it is the measure of how well your model is performing by comparing the predicted output to true output. Okay, so this will be your output, will be your loss function. So here we have objective. So the main objective, right, while we perform all this thing, will be to minimize this. Minimize the loss function. Okay, and we have some hyperparameters. So what are basically hyperparameters? Hyperparameters are your configuration settings. Okay, so like they are like parameters, right? You would be knowing what are the parameters are, but here we have a hyperparameter. So they are basically, you think of them as a setting, external. Okay, external setting to the model that affect its performance. Okay, so like the example to give you, like a learning rate. Like in some algorithms we have a concept like learning rate. So basically what it do is, here you get while you do modeling, while you model, your model will come up with a number. Okay, certain number. Like you may think of it as a, like while we were doing the missing value handling, right? Remember you said that how we come with that specific number. Suppose I am using a certain number like 26 for replacing with its age. Okay, so the question will be that how I came to this exact number 26. Okay, so in machine learning we also have to have some numbers, but how we come through across that exact number. Okay, so here what we do, here we use a concept that is your learning rate. We start with any certain number, any random number. I will start with, suppose say 22, random wild guess. Okay, now I will check the accuracy of our model. Now it is very low. So what I will do, I will use a learning rate. I will multiply this value with certain number. Like suppose I am multiplying this value with minus suppose say minus 1 point something 1.2. okay, so it will give me some output. So this is your learning rate. So every time whenever you run this, not 1.2, basically it should be smaller. Okay, so it should be like something 0.01. so this will be your ideally your like learning rate. Like your new value will be something like 2.2 in 0.002. Now it will check for this value. If this is closer to the, it will means if it increases the accuracy by little bit, that means we are going in a right direction. So it will keep on going. On the next step it will multiply this value with this learning rate, the same learning rate. So now it gets some value like 2.2004. Okay, for example, now it will see do the accuracy increases or not. The accuracy increases, yes, that means we are going right. Now again, same step, it will multiply with this value learning rate, again it gets some value, accuracy increases, yes, and it will keep on going until the accuracy gets saturated or it is not increases anymore. Now I got some value like 25.0 to say 25.900. Now if I will see that now my accuracy is not getting more, now my accuracy is not increasing, right? So now at end I got this value, that if I got this value, this will be the best fit for my particular example of for particular use case of it, where I am using that. Hmm. This value, so this was a wild guess. So now the catch here is this learning rate. If you take it too big, like if I say I will take to 1.5, it will jump on a wild, like it is going 20 22, on the second time it came like 30, right? Now the accuracy is decreasing because I am going farther away from this point. Now if I multiply it again, I make some changes on this learning rate, then when I will now what I will do is I will perform a code that if my accuracy tends to decrease, change this learning rate by minus 1 point this. So if my accuracy is getting decreased now, which is now, so I will multiply this value with minus 0 point something. Okay, so if I will use this value bigger, now again bigger, so it will get again like 21 this time because our learning rate is high. Okay, so that's why it is optimal that you use your learning rate something like 1.01 or 1.0, like in 2 or 3 decimal place. Okay, so now see if I will use learning rate something like this 0.0001, what problem here I will get this, it will take too much longer time, it will go like for 1000 iteration or more, and then at last it will come with some value like this, and when we are doing with a higher value, so it is like jumping here and there, like it came there and again came there. So our motive is to, like here if I draw the diagram of here, our motive is to fall here, right? We are at some points like here or here. Okay, so in minus or in plus. So we use learning rate. If our learning rate will be too low, so it will take too much time to come here, 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 right? If I will use a huge learning rate, so it will jump like this, like this, like this, and now here it came like this. Now it says that accuracy decreasing. Now it will come again like this, like this. So it will go jumping like here and there, right? Because my learning rate is higher. So this is now this will be your task to take a optimal learning rate. You will keep on changing this value. Okay, so you will play with this value here, this learning rate. So it will at the end give you a value that will be a best fit for your model, or like for filling the missing value or whatever you are doing with it, or you are using with it as a hyperparameter, right? Like for configuration your setting, right? Okay, so these points were for your key components. So these are your key components whenever you are dealing with your machine learning: your feature label, your training set and test set, model, loss function, and your hyperparameters. Okay, so now comes your workflow. Yeah, let's me quickly do it. Okay, so wherever you have the confusion or doubt, let me know. Okay, so I will be going through it quickly. Okay, so now you have your workflow. Okay, uh, yes, so our first point is the first step will be your data pre-processing. Like the sum of these the step here we have completed pre-processing. Okay, so it includes like the part things like your cleaning data, like removing the missing values, handling the outliers. These all things comes in cleaning your data, right? Seeing the outliers, removing them, replacing them with the new values. Okay, so these are the your this comes under your data pre-processing step at the first step. Okay, as I told you that the 70% of the data time is spent here. Okay, now the another thing is you have to do is scaling. This also I have explained you in a one lecture, I guess. That is your standardization and normalization, right? Like you have to make the all the values in standard. Like you will be having like some values in kgs, some value will be in your grams, like the 1000 grams. Now if we compare this value and this value, our model will say that yes, 1000 is greater than 1. But if it will check that this value and this value, it is these both values are equal, right? We know, but our computer will be not knowing because it will be given just this much data. So it should be scaled, or it should be standardized, right? The data should be standardized or normalized. Okay, so after this we have to perform encoding that we have seen on this video in this lecture as well. Okay, like the encoding is like one hot encoding or your ordinal encoding. Okay, like converting your categorical variables into numerical variables. Okay, after this your data pre-processing is done. Now your step comes like your training your model. Okay, so in between you also have like your visualization, but you do that all the thing while cleaning your data only. Okay, like cleaning your data, scaling and encoding the data visualization step. Okay, the basically your EDA thing. Okay, now your training your model comes into place. Okay, so now here the important thing is your learning algorithm. You have to choose the algorithm that will adjust the model's parameters during training. You will adjust them, adjust or try to change them and see if it improves the accuracy. Adjust the model's performance. Okay, so this will be done while you're training your model. This step, okay, while you're learning your algorithms. Are you there? Hello, are you there? Can you hear me? Hello, I think I have some bad connection, internet connection. Okay, so can you hear me now? I think there was some problem in my internet connection. So I was and so now I'm using my mobile hotspot. So do you have any problem till now? Means like any doubt till this? Huh. So now you can see, right? So I can just finish this topic because two or more things are left. Okay, now we can do this tomorrow because there are some topics to understand. Okay, so any doubt till here, like this training your model? Okay, 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 bye. Okay.